Good morning, everyone. I'm Joseph Sanwan of AgriBusiness Corporation, and I'd like to introduce to you the speaker for today. He is a chemical engineering from Mapua Institute of Technology. He has over 30 years of experience in sales, marketing, business development, and management expertise. He was past president of the Rotary Club Pasig West, and he serves as lector commentator of St. Francis of Assisi Parish in Mandaluyong City. He's also marketing and technical consultant for three packaging firms, namely Omnipack Industrial Corporation, JRD Manufacturing Corporation, and our company, RP Trading Corporation. Please welcome the speaker for today, Mr. Benji Tan.
Okay, get a round of applause. Come on. Okay.
Thank you.
As you know, Joseph is the COO of RP Trading. He's the child of the owner. So, welcome to our presentation for today. The millennial in me would have said that the title for this presentation is #AMAP at MAP. However, the baby boomer in me prefer to use go AMAP, no AMAG. So what is AMAP? It's an active modified atmosphere packaging, which is an innovative, safe, and natural approach for shelf life extension of fresh produce. So everybody would be familiar with fresh produce. So what is AMAP technology? It works on the principle of air transmission value and the right packaging. So the air transmission value is dependent on the weight of the fresh produce, the temperature used in the storage and processing, and also the respiration rate. Fresh produce comprises what Mr. Pamintuan has been moving around would be fruits, vegetables, and cut flowers. Similar to humans, fresh produce needs oxygen to stay alive. And the absence of oxygen, or the lack of it, would cause spoilage and eventually death of produce. So the life process of fresh produce would be similar to the human, would be respiration and transpiration. So the carbohydrates is converted into starch by the enzymatic process, and this starch is converted into simple sugar or glucose. And upon oxidation, meaning when you introduce oxygen, products would be carbon dioxide, like when we inhale, we exhale carbon dioxide, moisture, and energy in the form of heat. Respiration rate is directly proportional to temperature, and each produce would have different respiration rate. In this example, the blue represents blueberries and the red for the strawberries. Strawberries would exhibit higher respiration rate than blueberry. It's the same berry line, berry fruit line, and yet it has different respiration rate. And as you will note, the higher the temperature, the higher the respiration rate. So, just to remind us on the air composition, because we're talking about modifying the atmosphere. So, as we are familiar with, nitrogen is the biggest concentration of air, and followed by oxygen, which is about 21%. We will now focus on oxygen and carbon dioxide. In modifying the atmosphere, you reduce oxygen to slow down maturation or aging. As the fruits, the flowers, the vegetables mature, they produce a lot of ethylene gas. Ethylene is a natural hormone in all the fresh produce, and it is the catalyst to ripen the fruit, the vegetables, and the flowers, and eventually reach its natural state of decomposition. So you reduce oxygen, you slow down maturation, similar to animals hibernating during winter. So they consume less oxygen so they could last longer. And secondly, we increase carbon dioxide. Why? Because it is a natural fungicide. So fungus causes mold. And mold is what we call AMAP. So that's the reason I coined our presentation, Go AMAP, No AMAP. So, in a nutshell, a modified atmosphere inside the right packaging would reduce the aging process and at the same time enhance or extend shelf life of the produce. How do we get the air transmission value? So we use a respiration meter. I'll show you. Here is the fast respiration meter. The produce is monitored, and the respiration meter will calculate for the respiration rate of the said fresh produce. The results will show the level of the oxygen and carbon dioxide in relation to the temperature. So this is a typical example of the results shown by the respiration meter using the green rates as an example. And it will optimize the oxygen and carbon dioxide level inside the packaging. It is controlled automatically. There's a laser that will punch the holes. It's micro holes, cannot be seen by the naked eye. It's about between 70 to 100 microns. By the way, 1 micron is 0.001 millimeter. So, talagang maliit siya, no? This is a typical example. As you can see, a 350-gram broccoli packed in that packaging would only require 5 holes to get the right transmission value. So, why Flex Fresh Liner? This is the ideal packaging for the modified atmosphere. So, it's environment friendly. It's a bioplastic composed of plant extracts, 100% biodegradable and compostable, as certified by a third-party independent testing lab, Intertech. It minimizes weight loss, which is a very, it's a big factor really in the transport of fresh produce. It controls bacterial and fungal infections because of carbon dioxide. Keeps the fresh produce dry. You're familiar with Cavendish bananas, right? So when it reaches the destination, it's wet because of condensation during transport inside the PE vacuum bag. With Flex Fresh Liner, the banana stays dry. There's an exchange of moisture. The plant extract inside the bioplastic will absorb the moisture, and when the fruit requires back the water, it will give it back to the banana. That's why most expensive and highly perishable produce are exported by air. And air transport would be more expensive than shipping it by sea. Using this alternative packaging, you can now export longer distance via sea. Just to give you an example on the impact of weight loss on Cavendish banana. Average annual volume is 150 million boxes of banana in 13.5 kilos. The exporter would pack it at 13.5 kilos per box. As the destination, the market would require a net weight of 13 kilos of bananas. So to compensate on the weight loss, they pack more. Using this technology, based on several trials, the average weight loss amounted to 0.3%. Meaning, if they only pack it at 13.1 kilo per box, they save 0.4 kilos per box. That would translate to 60 million kilos savings. That's for banana alone. In Holland, in the Netherlands, they're now into waterless internet flower pack. Can you imagine shipping or transporting flowers without water? With a base life guarantee of 7 days. It stays fresh for 21 days and they still guarantee 7 days base life upon opening and putting it inside the vase. Here's a video of Lumpo showing how the technology works. Okay, that is the fast respiration meter which assesses the flower's respiration rate at the required chain temperature. It automatically computes for the respiration rate. And underneath, you see a roll of film. It passes through a laser which punches the hole before it is packed.
Yep.
And you will note a camera that monitors the whole size. So basically, the active modified atmosphere plays on the level of oxygen and carbon dioxide inside the packaging.
Those are flowers. Oh, flowers.
Those are fresh cut flowers. So there's no water. Then you can include chocolate for your loved ones. Yeah, for Valentine, you can order from Holland, tulips, whatever. Those are the chocolates. So it depends on the flowers, depends on the produce, respiration rates, and the transmission value will vary. And those are okay, huh?
You're selling machinery or the service?
The packaging. It's just a way of showing. It could be mechanized automatically, but the secret is in the respiration meter, computing for the respiration rate and the transmission value and the right kind of packaging.
That is the local. Is that local?
That's in Netherlands.
Netherlands, yeah. When are you going to do this locally?
Very soon. Okay, we're in the process of conducting trials mostly in Mindanao, and we also have successful trials in Tarlac for okra. In Mindanao, it's for pineapple and banana, and there are also going trials for avocado. Dole is the biggest exporter of avocado. In India, pomegranates were being shipped via air before. Now it's being transported by sea. There's also a shipment of mangoes. It's a Kesar variety, and as you can see, after 27 days, still green and fresh and firm. Yeah, that's from India. Papaya trials in Brazil for 30 days. Left one is in Flex Fresh Liner, and this is their present without liner bag. You can see Flex Fresh is a better food quality. In Egypt, trial on apricot for 50 days. Where's the food? Okay, sorry. If you will note, there's AMAG here. You can see it. That's in their present, ordinary, non-biodegradable biodegradable plastic. And this is the
That's
biodegradable.
fungus, right? Fungus ni AMAG. It's fungus.
Fungus, yeah. Mold. Mold or AMAG caused by fungus. Trials was also done.
But some AMAGs are edible.
Yeah.
Cheese.
Yes. So in Israel, for avocado, you can see the difference between the left and the right. And these are in Flex Press Liner. And these are the ordinary plastic. Rambutan for 20 days, stays fresh. Here in the chili blueberries, from packing to 50 days, control has more AMAP, and this has almost none. Green chilies transported by sea. You will note some ripening here. They are still fresh and green. See, plenty of ripened chili.